नमो तस्स भगवतो अरहतो सम्मा सम्बुद्धस्स। नमो तस्स भगवतो अरहतो सम्मा सम्बुद्धस्स। नमो तस्स भगवतो अरहतो सम्मा सम्बुद्धस्स। बुद्धं शरणं गच्छामि, धम्मं शरणं गच्छामि, संघं शरणं गच्छामि। द्वितीयंपि बुद्धं शरणं गच्छामि, द्वितीयंपि धम्मं शरणं गच्छामि, द्वितीयंपि संघं शरणं गच्छामि, तृतीयंपि बुद्धं शरणं गच्छामि, तृतीयंपि धम्मं शरणं गच्छामि, तृतीयंपि संघं शरणं गच्छामि। पाणातिपाता वेरमणि सिक्खापदं समाधियामि, अदिन्नदाना वेरमणि सिक्खापदं समाधियामि। कामेषु मिच्छाचारा वेरमणि सिक्खापदं समाधियामि। मुसावादा वेरमणि सिक्खापदं समाधियामि। सुरामेरयमज्जपमादठाणा वेरमणि सिक्खापदं समाधियामि। सब पापस्य अकरणं कुशलस्य उपसम्पदा सचित्तपर्योदपणम् एतं बुद्धान शासनम् साधु साधु साधु।
जय भीम, नमो बुद्धाय। हैप्पी इवनिंग एवरीवन। दोस्तों, सो चांद भी आ जाए तो शो में बात न रहेगी। सो चांद भी आ जाए तो शो में बात न रह जाएगी। सिर्फ आप जैसे दर्शकों के आने से इस टॉक शो की रौनक बढ़ेगी। इस टॉक शो की रौनक बढ़ेगी। फिर एक बार आपका इस शो पर स्वागत करता हूं। मुझे आशा है कि आज का ये सत्र आपके लिए आकर्षक और समृद्धि होगा। दोस्तों, वर्तमान समय में समाज को बदलने के लिए, जैसे कि कंप्यूटर, मोबाइल और इंटरनेट, और आज का जो हमारा शो है क्लाउड कंप्यूटिंग टेक्नोलॉजी, सबसे बड़ा साधन है आज के तारीख में। हमारे जीवन से जुड़ी हर चीज से को देखता है, जैसे कार्य करने की शैली, जीवन का साधन, संचार मार्ग, ज्ञान का निर्माण करना इत्यादि। So what is the cloud computing technology? An introduction to the cloud computing, right from the basics of like LAS, LAS and PaaS, hybrid, then public and private. आपने सुना होगा कि AWS, और अभी जो लेटेस्ट है दैट इज नाउ Azure। आज के समय में कंप्यूटर एमबी उपयोगिताओं की संकल्पना लगातार बढ़ती जा रही है, जिस कारण डाटा स्टोरेज सभी क्षेत्रों में प्राथमिकता दी रही है। सभी प्रकार के, जैसे कि आज आईटी सपोर्ट, और जैसे कि एक स्टोरेज हब की जरूरत पड़ती है। तो दोस्तों, आज इस शो को हम लेकर आ रहे हैं, जिस शो की वजह से हम पता चलेंगे कि क्या व्हाट इज क्लाउड कंप्यूटिंग, फिर उसके फायदे के, हाउ डज इट वर्क्स, इस बहुत सारी चीजों के बारे में। प्राइवेट क्लाउड क्या है, फिर बाद में कम्युनिटी क्लाउड क्या है, इस टाइप की अलग बहुत सारे क्वेश्चंस आज हम सभी को बता देंगे इस माध्यम से। आज इस शो के लिए हमारे सामने, इस शो की गरिमा बढ़ाने के लिए, आज हमारे यूएस से हमारे अच्छे दोस्त है रामा कृष्णा जी, जो हमारे साथ बने रहने वाले हैं आज। तो मैं उम्मीद करता हूं कि ये इनके बारे में थोड़ा परिचय देना चाहता हूं कि वो 20 साल से इस एरिया में काम कर रहे हैं, और एक उनके बारे में एक और अद्भुत ऐसी बात है कि उन्होंने यूपीएससी जैसे एग्जाम क्रैक करके उन्हें आईआरएस में भी चुना गया था, बट उन्होंने वो छोड़ के आज जो इस क्लाउड कंप्यूटिंग के बारे में बहुत सारा ज्ञान लेना है, और आजकल लोग यूएसए में है। तो मैं उम्मीद करता हूं कि इस शो के बारे में आपको जरूर ज्यादा से ज्यादा इंफॉर्मेशन मिलेगी, और ये शो बेहतरीन हो जाएगा। तो आपसे मैं अनुरोध करता हूं कि इस शो को आप ज्यादा से ज्यादा लोगों को और भी ज्वाइन करने के लिए बोलेंगे। So we welcome Mr. Ramakrishna from USA. Yes, sir. Over to Krishna, sir.
Okay, so let's get started. Shall I
Yeah,
start
sure.
sharing my screen?
Yeah,
Okay, I'll share my screen.
yeah, sure.
And then entire screen. And can you see?
Yeah, sure.
Okay, good. Good evening, ladies and gentlemen. This is Ramakrishna, and today we're going to talk about cloud computing. So, a brief introduction about me. I have been in the industry for software industry for the more than 25 years, and previously I worked for AOL, Verity, Cisco, and HPE, and I have been working on cloud technology since 2013. And I'm a graduate of computer science and engineering from JNTU, and I also have an MBA from Santa Clara University. And the reason I am actually giving this presentation is because I love technology, and I would like to teach, and I would like to share my viewpoint on technologies, and then as a way to inspire students and others who want to work on the latest technologies. So aside from what I do, I mean, at work and with technology, I'm also an active hiker and a movie lover. I follow tennis and soccer. So let's get started. So the agenda for today. So today we're going to talk about what cloud is. We're going to talk about history and evolution. We're going to talk about public cloud and the market. We talk about virtualization. We talk about containers. And then we can also talk about Google Cloud Services, or I can give you a demo of it if that's needed. But this is going to be a very generic cloud presentation. So what's cloud? So one question. So how do I know if anybody is looking for my attention? Let me come back. Where is my? Okay, I think let's get moving. Sorry about the interruption. So today we're going to talk. So let's talk about what cloud is. So cloud computing is the use of hardware and software to deliver a service over a network. It's typically the internet. Now, how do you achieve that? So you have platforms like SaaS, which is software as a service. You have platform as a service, also known as PaaS, and you have infrastructure as a service. We call IaaS. So let's look at the evolution of cloud and then the history of it. So if you recall, in the 1960s, we used to have mainframes. And these mainframes used to work on the time sharing model. So essentially, you have a mainframe in one central location, and then we had these terminal devices spread around. And using the terminal devices, we used to access the server. So it's kind of a flow over the internet, kind of a communication. So that you can classify that as something that how a remote kind of a cloud computing started. Now, the definition of what constitutes cloud, it kind of changed over decades, but that was the early entry into what we call as a cloud. Now, in 1969, there was this ARPANET, which essentially was able to help integrate various devices and then computers. And then sometime around 1970, we had this virtualization software launched. Now, although the virtualization back that time, it was very primitive, and we're going to talk about what virtualization is. And there was the time when the initial software, initially the concepts of virtualization started coming up. And then in 1991, we had the World Wide Web coming up. Now, one of the earliest definitions of cloud computing was given by Rama Chellappa. first companies to do what we call a software as a service. For example, you might ask, what is software as a service? And a good example would be, right now you're streaming this video. Now this video is happening over the internet. It doesn't need any installation from your end. All you need is a computer and your mic and cam, and that's it. You're kind of online. So a service is being delivered over the internet. So that's we call a software as a service. And we will dig into it in depth over subsequent slides, but that's where software as a service started. Subsequently, in 2006, Amazon launched the true cloud services that as we know of today. So Amazon launched Elastic Compute, which we call as EC2. Amazon also launched Simple Storage Service. So Simple Storage Service is one of the earliest cloud computing technologies. Now there is a story about how Amazon got into cloud services. So Amazon, when it was expanding, and the company accidentally bought huge amount of excess hardware, and the company couldn't figure out what to do with it. And then just around the time, the virtualization concepts kind of grew up, and Amazon took advantage of virtualization to offer cloud computing services. And then soon after, so many other players came into being. Now, as you noticed, that the demand for cloud technologies is exploding. So as of 2013, we had like 78 billion pound worldwide public cloud service market alone. Now, in the current, it's almost like 200 or 300 billion, and it's growing at a much faster rate. Now, we don't have to go deep into those figures, but I can tell you that the estimated global cloud spending across the world is actually going very high. Now, let's look at the cloud market the way it is. Now, you see that one of the big players is Amazon, and now which we call as Amazon Web Services. Now, there are other players, Microsoft Azure. Microsoft Azure came around much later, and Amazon is kind of the pioneer in this. And then we have Google Cloud, and we also have IBM, and we have Alibaba, Salesforce, Oracle, and so on. So these players are growing, and there are so many other small players catering to the niche market. Now, this is all fine, but then for a greater discussion, why should anybody choose to go to cloud? I mean, it's a valid point. So far, we have our own data centers, and companies are running their own services on premises, and it's all fine, right? So why would you have to go to cloud? Now, there are so many reasons why you would want to migrate to the cloud. As a business entity, you might want to reduce costs, okay, get access to a lot more services. So let's start with why any company, business entity would want to go to cloud. The first and the most important is the services on demand. So what does it mean, the services on demand? For example, you have your business entity and all your services hosted locally on premises. Now you want to spin off a database cluster, for example. What are your options? You can buy the hardware, ask your database administrator to install all the software that's needed, and it takes a couple of days turnaround, and it's or even a couple of weeks, because you need to buy hardware and you need to do planning and all that. But if you go on cloud, these services are readily available. All it needs for you to take advantage is sign up and get going in under 5 minutes. Okay. Now the second one, the easy access and agility. Okay. So how do you access these cloud services? Remember we talked about cloud is all about being able to access any services over the network, internet typically. So you can log in from any device, laptop, or sometimes in mobile devices or tablets, and access any of the services that you want on the cloud. Elasticity and auto scaling. Now, for some of you, these terms are difficult to understand. But what elasticity is? Now, suppose you have your machinery, your systems running on premises locally. Now, the demand for your services are growing. So, how do you manage? Now, during peak season, let's say December shopping. Okay. Now, there's a whole lot of demand for your services, but then subsequently months later, the demand kind of slows down. But how do you manage this if you need to manage your hardware resources? So one thing is, if you go to cloud, all these resources are elastic. For example, if I want to have an access to a cluster, your database cluster, for example, okay. Now, as the demand for your database services increases, the cloud will be able to automatically provide additional resources. So you don't have to ask. Now you can configure your system, say, I need 2 more resources when the demand reaches peak, for example. Yeah, they are automatically provided. So the ability to automatically provide is what we call elastic. And then when the demand falls down, the resources shrink. So that is typically what elasticity is. Now, how do you do that is what we call auto scaling. So pretty much those two terms are very similar. So that's the essence of why you would want to go to cloud. I need elastic resources, cheaper and better return on investment. Okay, so how is going to cloud cheaper? Now, one thing, cloud is all about pay as you go. So there are no upfront costs. So you don't have to buy hardware. You don't have to hire any engineer to configure that. There's nothing. There are no capital expenses to be incurred. So you rent these resources and give it back when you don't need them. So that's the whole model of cloud. So that's why they're cheaper and better, and they give better return on investment. And it's also highly secure because these resources on the cloud are hosted on data centers that are very secure. I mean, they have physical security in terms of fencing and then monitoring and everything. And then access to those facilities is very, very tight. So you can pretty much assume that whatever data or your applications that are running on the cloud are very secure. Global network of resources. So, okay, so then you might ask, are the resources available within my reach? Yes. So both Amazon, Google, and Azure, they have resources spread out throughout the world. So, for example, Amazon has cloud resources in Asia, in Germany, in UK, and so on and so forth, in the United States, and so on. And there are multiple centers. So you don't have to host resources in some faraway country and then access them remotely. So all that is kind of taken care of. Now, easy backup and recovery. So one of the things that cloud automatically provides you is the ability to back up your resources. You have data in your database, so you can take frequent backup, and your database server fails, and then you can recover them. High availability. So what does high availability actually mean? So what high availability means is that these resources are available for you 24/7. So there is no downturn, which means, for example, I remember back when I was working, 10 years back, if the mail server had to be upgraded, we used to get a mail that email won't be available from 12 to 5 p.m. So during that time, email system will not work because somebody at the back end is trying to upgrade the systems. Okay, so you can't call that kind of service as available 24 by high availability. Now in the cloud, maintenance are automatic, and there is no turnaround time. So you don't have to wait for the services to come up. They are always up and running. And another more important advantage is that you move away from capital expenses to OPEX. So what does it mean? It means that you don't incur any expenses upfront. Now, if you remember, on when you're setting up a data center on-prem or within your company premises, you need to buy hardware, you need to buy space, rent out space, and then install equipment and all that. All that is not required when you're in the cloud because they're already built for you. All you need to is to get the access. Okay, so that's all about why would we need cloud, and that is kind of very important for us to understand as we move forward. Why companies would want to move to cloud. Now, there are challenges. I mean, does every business entity want to move to the cloud? Well, there are some situations where cloud may not be the ideal situation. Security and privacy. Now, although resources on the cloud are very secure, there are some concerns. Some companies still feel that their resources are better protected on premises, but I think that is their choice. So that's why they want to keep their data on premises. Now, some business units may want very, very low latency requirements, which means they expect these resources to be hosted on-prem. So you can expect very low latency. Although going to cloud has actually, now even these days, cloud is very fast, but for some reasons, you may want to host your resources on premises. Government regulation. So how does government regulation is actually a challenge? Now, if you for some countries in the, let's say in UK or Germany, for example, now the regulation is that all the data that belongs to the German citizens must stay within Germany. So if a cloud company does not have a data center in Germany, then it really cannot take the customer in. So that's the kind of government regulation we're talking about that will prevent companies from moving to the cloud. Now, portability and proprietary systems. Now, some systems, the way they are designed, it may not be exactly portable. Proprietary systems. Now, you have proprietary system designed within your company, and the cloud may not have the same systems for you to accommodate them. So in which case, you might want to stay on premises. So what are the cloud service models that we are aware of? If you remember, we talked this briefly. You have infrastructure as a service, and then you have platform as a service, and you have software as a service. Now, what is infrastructure as a service? Now, this is one thing that's very important. So when you say infrastructure as a service, it's all about compute, storage, and network. So it's like I want this pure hardware. Now we are not talking about applications. It's compute, storage, and network. Now, and above that we have platform as a service. What is platform service? Now, I would say, I want a platform like a database, okay, and cloud can provide you that. And then you have SaaS. What is SaaS? Now you're accessing Gmail. Now you can sign up into Gmail, create an account, and then use it. So that's a good example of software as a service application. Now we'll go into detail with all of this subsequently. So even if you don't understand it, but no worries, we're going to cover this again. Now, what is software as a service? So I say software as a service is a software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted, mostly dealt by end users and consumers. Now, one of the big providers of software service are ServiceNow, Salesforce, Workday, Atlassian. You may be familiar with these products, but how do you access it? So all you need to is go sign up and then use it. That's as simple. Okay. Now, platform as service. Now, what is a platform as service? It's a cloud computing model where a third-party provider delivers hardware and software tools to users over the internet. So mostly developers work in PaaS. So when you think of software service, it's mostly users and consumers are the one that are using software as a service. When it comes to PaaS, it's developers who are working. Now, a typical PaaS platform would be Elastic Beanstalk, VMware Pivotal, Red Hat OpenShift Container Platform, and Cloud Foundry. Now, Next, we'll go to infrastructure as a service. So infrastructure as a service is a cloud computing service where enterprises rent or lease servers for compute, network, or storage in the cloud. Network admins manage these resources. Now, some of the companies that we talked about: AWS, Google Platform, Microsoft Azure, Alibaba, Rackspace. Now, these companies provide you infrastructure as a service. So essentially, you talk to these companies and say, I need 25 virtual machines configured via 2 networks and 2 terabytes of storage. So that's what we talk about infrastructure. It's not about applications. It's about resources, fundamental resources, the hardware resources. So now, whatever we discussed, we discussed about why would anybody move to cloud, and we talked about various forms of services that cloud provides. But something must be happening behind the scene to facilitate cloud. How is it easy to do all this stuff? Now, one of the concepts that you always hear when you talk about cloud is virtualization. Now, for some of you, this virtualization concept may be challenging, but but don't worry if you don't understand completely. But I'm going to briefly touch on what virtualization is. Now, virtualization itself is a huge concept. If somebody has to teach it, it's like more than a couple of days of conversation. So one of the important things is that in the cloud, all resources are virtualized. Everything is virtualized. So let's take, for example, the compute. When you think of the compute resources, they are more like virtual machines. Okay. Now, virtual machines run on hypervisors. So you have a hardware and you have your operating system running on top of it, and then you have hypervisor. Now, hypervisor initially came out of, several companies contributed to developing a hypervisor, but hypervisor came out of a company called predominantly from VMware. Now, what can you do with hypervisor? Now, essentially, you can take a good example would be you can take one laptop and create 3 miniature laptops inside that. Now once we have that, it's like the game changes. That's a very simplistic definition, but think about on those lines. So in real life, Amazon or Google or Microsoft Azure, what they do is they have hardware, install OS, and then predominantly it's hypervisor that is doing all this. Okay, on the hypervisor you can launch multiple virtual machines. So that's about compute. Now, whatever is happening to compute, it's also happening to the storage. Now, which we call it storage virtualization. Storage is like you're storing your data, okay, which we call software-defined storage. Now, with software-defined storage, what you get is you get a very highly resilient, redundant storage system, which you can rent it, and once you're done, give it back. No more charges. Okay, so it's that simple. Enabled multi-tenancy. So what is enabling multi-tenancy actually mean? Now, you can actually have one piece of hardware and host multiple tenants, which means, like in our example, multiple businesses are using the same resource, and thanks to hypervisor and then the separation, they don't know about each other. Okay, so the separation of services, it's very well managed. So that's what fueled facilitated cloud, because customers would want multi-tenancy. Software-defined networking. Okay, so well, you have all these resources, and all these resources must be networked in some way. So there comes the software-defined networking. Now, here we talk about virtual switches, virtual routers, network function virtualization, and so on and so forth. Okay, and then most recently, what happened was, this happened like 10 years back, containers and Kubernetes came along. Now, we'll talk briefly about this. And then cloud native, being able to run your applications and make them portable across clouds. So that's a big thing about containers and cloud native. Now, as we talked about briefly about virtualization, and virtualization is important. So in the traditional architecture, you had hardware and you had operating system, and you had the applications. Now, if you look at it, there's only one business unit can make use of it. Okay. Now, with virtualization layer, what can you do? You can have a hardware, and you have virtualization layer, and you have multiple operating systems running on it, each owned by a different company, different business unit. So ultimately, what virtualization is helping you is to optimize on your hardware resources. Now, let's briefly talk about containers. Although containers is a very challenging idea and concept for you to understand, but I'm going to cover very briefly so you can understand what is happening. So containers are lightweight, isolated operating system environments running on a host. Unlike virtual machines, containers do not need hypervisor. All containers on the node share the same operating system. They're essentially processes, and they achieve strong isolation using kernel features. Now, why is the industry moving towards containers? I think that's one very important concept that we should understand. So from the business point of view, it is all about optimizing your resources. So which means you can do more stuff. You can do more. You can launch more applications on the same hardware resources. So which means it will become cheaper to run applications. So the cloud is all about going cheap, right? It's all about going cheap. Now, one of the important thing about cloud virtualization is that one of the most important thing about containers is that you can run in a very isolated manner. Okay, that is from the business point of view. I mean, you need efficiency, you need speed, and cheap. It got to be cheap resources. Now, from the development point, from the engineer's point of view, now we are going to make our applications portable, very easy to run, and very fast. So containers run very fast. Now, container is all about standardization. I think you can see from the picture, the analogy is brought up from the shipping world, where you put everything in one box, and the box get onto the ship, and then the same box will come and sit on a train, and then the same box will again sit on a trailer. So it's all about being portable. Now, portability achieves a lot of things. It achieves consistency, and then being able to move from one cloud to another cloud, or it can mean going from on-premises to public cloud. So, okay, containers are fine, okay, but then at some point you'll have the need to manage these containers. Okay, these containers have to be managed in some form. So, which is what we call as orchestration. Now, there are several orchestration engines, but Kubernetes is one of the dominant container orchestration engine. Okay, so let's talk about Kubernetes. So it's essentially an open source container orchestration engine from Google. It automates computer application deployment, scaling, and management. Now, think about efficiency, right? How do you deploy your applications? Now, it's getting simpler and simpler. Okay, all that is automated using Kubernetes. It's highly agile and extensible. So what does it mean? You can stretch it. Speed of deployment, speed of development, desired state versus current state. Now, with reference to Kubernetes, and you have an application to be deployed, so you give it a state, which means I need this many resources to be made available, and then Kubernetes will make sure that it meets the requirement. So remember, we talked about being scalable. Okay, so Kubernetes also helps you to horizontally and vertically scale your applications. Okay, that's fine, but what does it really mean, being able to horizontally and vertically scale? So essentially, it means that when your applications are running out of resources, okay, so additional containers are created to handle them. That's one thing. And second thing, If those resources are not enough, then Kubernetes will help you spin another node to launch new containers. So it will scale as the demand goes up. Rolling updates with zero downtime. So what does this mean? So what this means is that when I want to have a newer version of the application, I can install the newer version and there's no downtime. Automatic upgrades are available. So you can automatically upgrade your containers, and even the nodes are automatically upgradable. So essentially, it boils down to reduced operational expenses and infrastructure expenses. And that's the very reason why businesses migrate to cloud. Sorry about the interruption. Okay, types of cloud. So you must have heard of public cloud, right? So a public cloud is a multi-tenant platform. Now this is a very thing that is very important. It's a multi-tenant, which means there are so many other business entities who are sharing your resources, and they are there along with you. Okay, so it's a multi-tenant platform that uses a standard computing model to make resources such as virtual machines, applications, or storage available to users remotely. Public cloud services may be free or offered through a variety of subscription or on-demand pricing schemes. So what is a good example of public cloud? Amazon, Google, Microsoft Azure. Now, private cloud. Private cloud is a computing model that offers a proprietary environment dedicated to a single business entity. Now, here is what is different. Private cloud is about a business entity exclusive to a dedicated to a business entity, or it could actually be a set of users. Okay, and as with other types of cloud computing environments, private cloud provides extended virtualized computing resources via physical components. It could be stored on-prem or at vendor's data center. So it doesn't matter, but private cloud is exclusive for one customer, one business unit. Okay, so one of the very leading products that provides private cloud is OpenStack. Okay, and then we also have hybrid cloud. Okay, so what does hybrid cloud mean? So essentially, hybrid cloud means a mix of public and private cloud resources located in both private as well as a public cloud. So one good example would be you could have your resources on premises, okay, and some resources on the cloud, and then they are both integrated using a advanced networking capability so that there's communication. So that's a good example of a hybrid cloud. And one of the things that is a facilitator is also about moving applications back and forth. Now, some of the technologies that provide hybrid cloud are Google Anthos, and then you have Red Hat Advanced Cluster Management. Okay. Now, let's talk about the top cloud providers that we have. So some of the top cloud providers are AWS, Salesforce, Amazon, Alibaba. You have Google, and so on and so forth. Rackspace is another public cloud provider. Now, let's briefly talk about individually. So the Amazon AWS is by far the largest cloud provider. Okay, and it provides a plethora of services. Now, how many services? There are like over 200 services are provided by Amazon, and it has a very high penetration in the market. And Amazon AWS covers nearly 45, earns almost 45 billion annual revenue. I mean, that is pretty huge. Now, what you see in the pictures here are some of the services provided by Amazon. Okay, Amazon DynamoDB, Amazon S3. Amazon S3 is a storage service. Amazon EC2 is a compute service. and Amazon AWS is the Lambda service, which essentially means serverless. Yeah, so those are some of them. And you also have Microsoft Azure. So Microsoft Azure is the second largest cloud provider. It capitalizes on businesses with Windows installation. It has very fast growth, and essentially most of the Windows customers migrated to Microsoft Azure. And then you also have Google Cloud. Google Cloud is the third largest provider, and Google Cloud provides cutting edge cloud technologies, and it has very fast growth. And now what we have is some of the technologies that Google provides. Now, one of the things that I want to bring to your attention is cloud technologies employment potential. Now, cloud technologies are expanding. So as we have seen, pretty soon, cloud technologies would be like a $500 billion market. Now, cloud technologies took advantage of plenty of open source technologies that came along, and these technologies are being absorbed at a very, very rapid pace. Now, this kind of creates a problem. What's the problem? There is a talent shortage in cloud technologies. Now, companies are looking for people to find skilled engineers to meet the potential gap. There's a huge demand for these technologies, but then the supply of engineers is not that high. So essentially, what this creates, it creates a situation where there is a huge employment potential. Now, what companies are doing is it's making a lot of resources available for learning. For example, you can go to Google resources, go to Google, search for, go to Google Cloud, and then there are plenty of tutorials for you to kind of learn these technologies. Okay, and then sometimes if even though there are free resources, but some guidance to learn this technology is kind of essential. But for those who are motivated, there's plenty of resources. Now, same thing with Amazon. Amazon has these sessions almost going on a regular basis where they kind of teach you about cloud technologies, and you can attend those sessions. But again, as I was saying, some guidance is kind of needed for students or even those who are employed to learn from these technologies. So now I'm going to open up for questions, and we can have a long question and answer session. Yeah, can you hear me?
Yes, sir.
Yeah, so let's open up for questions. I have time for questions.
No, before open forum,
Yeah,
Mr. Ramtike will join us shortly. Okay. So we'll have a short break. After that, we can start open forum later. Okay.
Okay. So how long is the break for?
Yeah. Before that, thank you, Mr. Rama Krishna sir, for giving us such an amazing information about the cloud computing technology.
Okay.
And its importance to our GBC viewers who have talents they wish to showcase to us the nearby future. So thank you very much.